So next I am going to discuss one special case. So I am going to discuss special case in one-dimensional inelastic collisions. You find number of questions based on this special case in different books, and also number of questions were given based on this case in the earlier entrance exam papers. You please stop writing now. You just concentrate only to listen. So I will show you the notes for this special case. I mean conclusions of the special case and calculation for this special case later. So now you just concentrate only to listen. So let us consider a rubber ball dropped from certain height h onto a horizontal floor. Let us suppose the ball is allowed to collide repeatedly. Let us suppose the ball is allowed to collide repeatedly with the floor such that the ball moves only under influence of gravity between two successive collisions with the floor. Let us suppose the ball is dropped from a height h above the horizontal floor and rebounds to height h1 after first impact with the floor. If there is no air resistance and the collision between the ball and the floor is perfectly elastic, as I discussed in one of the special cases in one-dimensional elastic collisions, the ball rebounds with the same speed with which it strikes the floor and rises back to the same height from where it is dropped. So here, let us suppose the collision is not perfectly elastic, it is semi-elastic or inelastic. So the ball rises to height h1 which is less than the initial height h from where it is dropped. So we consider the collision between the ball and the floor. So m1 is the mass of the ball, m2 is the mass of the floor. Let u1 be the velocity of the ball just before the very first collision. Before with the floor. Let v1 be the velocity with which the ball rebounds from the floor just after the first collision and rises to the height h1. So, but before collision between the ball and the floor, u2 is 0. That means floor is at rest. So initial velocity of m2, that is floor before collision, is 0. Final velocity of m2 after collision is also 0. That means v2 is also 0 because floor is at rest before collision and after collision here. So u2 is 0, v2 is 0. Using the Newton's formula for one-dimensional collisions, we write E equal to v2 minus v1 by u1 minus u2. Here v2 is 0 and even u2 is 0. So you get v1 equal to minus E times u1, or some of the books they write v1f is equal to E times minus E times v1I. That means the magnitude of velocity of the ball just after impact with the floor is E times the magnitude of the velocity of the ball just before impact with the floor. So, but the negative sign implies that v1 is directed opposite to u1. If u1 is directed downwards, v1 will be directed upwards. We give positive sign, suppose, for upward direction and negative sign for downward direction for velocities. So if you square this equation, both sides of this equation, you can write v1 square equal to E square into u1 square. So for motion before the first impact with the floor, the ball falls freely under gravity. So using the formula v square minus square equal to as, or vf square minus vi square equal to as for motion under gravity. So for motion of ball under gravity, so consider the motion of the ball under influence of gravity just before the first impact with the floor. Using this formula vf square minus vi square equal to as, or v square minus equal to as. The final velocity before collision is u1. Initial velocity at beginning of fall is 0. Acceleration equal to g, s equal to h. So you get u1 square is 2gh. Or magnitude of velocity just before first impact with the floor sometimes are denoted by v, that is root 2gh. So for motion of the ball after the impact with the floor under influence of gravity, v1 is initial velocity just after the collision with the floor. That means v1 can be taken as initial velocity for upward motion under influence of gravity after collision with the floor. At the highest position, final velocity is 0. So for motion under influence of gravity, using that formula, same formula, vf square minus vi square equal to as. At the highest position, final velocity is 0. Initial velocity for motion under influence of gravity in the upward direction after collision with the floor is v1. The acceleration due to gravity acts downwards. We write a equal to minus g, that's equal to h1. So you can write v1 square equal to gh1. Or you can directly write that maximum height reached after collision with the floor. After the first impact of the floor is given by h1 equal to v1 square by 2, using the formula for maximum height, which we discussed in kinematics. So from same equation, you can write v1 square equal to gh1. So now we can substitute u1 square equal to gh on the right side here, and v1 square equal to gh1 on the left hand side here. So if you substitute v1 square equal to gh1 on the left hand side here, e square into u1 square, you can write it as equal to gh. So the height or vertical height to which the ball rises after first impact with the floor is h into e square. So the final height to which the ball rises after impact with the floor is equal to e square times the initial height before the impact with the floor. So the ball is, let us suppose, allowed to collide with the floor repeatedly, so that in between any two successive collisions, the ball moves only under influence of gravity. That means we are not trying to catch the ball after the collision with the floor. We are allowing the ball to fall again and again and strike the floor repeatedly until it stops rebounding. So after any particular, the final height to which the ball rises after a particular impact with the floor can be written as e square times the initial height from which the ball falls before that particular impact with the floor. Let us suppose h. Now after first impact with the floor, it rises to the height h1. Then next the ball falls freely under gravity from same height h1 before second collision with the floor. So for second collision with the floor, h1 is the initial height from which the ball falls before making second impact with the floor. And h2 is the final height to which the ball rises after second impact with the floor. That means originally the ball is dropped from height h. So the ball first falls freely under gravity from height h before striking the floor for the first time, and rebounds to the height h1 after first impact with the floor. So for first collision with the floor, h1 is the final height and h is the initial height. So after it rises to the height h1, next again it falls freely under gravity from same height h1 before second collision with the floor. So after second collision with the floor, it rises to the height h2. So for second collision with the floor, initial height from which it falls, hi can be taken as h1 and hf is equal to h2. So you can write h2 equal to e square times h1. I can substitute h1 equal to h into e square from this equation. So you get h2 equal to h into e power 4 or h into e power 2 into 3. So to whatever height the ball rises after a particular impact to the floor, it again falls freely under gravity from same height before the next impact with the floor. So after second collision with the floor, it rises to the height h2. Then next it falls freely under gravity from same height h2 before third collision with the floor. So for third collision with the floor, h2 is the initial height. The final height up to which it rises after second collision, third collision with the floor, it denoted by h3. So h3 can be written as h2 times e square. That is using the same principle again. The final height to which the ball rises after a particular impact with the floor is e square times the initial height from which it falls before that particular impact with the floor. Can now write for h3, h2 can be written as h into e power 4 from here. So the height with the ball rises after third impact with the floor is h into e power 6 or h into e power 2 into 3. So you can observe h2 equal to h into e square, h2 equal to h into e power 4 or h into e power 2 into 2, not 2 into 3. And h3 equal to h into e power 6 or h into e power 2 into 3. Similarly, for fourth impact with the floor, we can write h4 equal to e square times h3. That comes out to be h into e power 8 or e power 2 into 4. So the height to which the ball rises after nth impact with the floor can be written as hn equal to h into e power 2n. So in general, if the ball is dropped from vertical height h above the horizontal floor and allowed to make collisions repeatedly, then the vertical height to which the ball rises after nth impact with the floor is equal to h into e power 2n, where e is the coefficient of restitution between the ball and the floor. Now, next we are going to discuss the calculation for speed of the ball after nth impact with the floor. Need not write running notes now. I will show you the notes separately for you in a systematic way. So magnitude of the velocity of the ball just before the very first impact with the floor, I denote it by V, suppose. That is equal to root 2 GH. Let Hn be the vertical height to which the ball rises after nth impact with the floor. That means H subscript small n represents the maximum vertical height to which the ball rises after nth impact with the floor. So for motion under influence of gravity after nth impact with the floor, Hn is the maximum height, which you can write Vn square by 2g. Here V subscript n represents the magnitude of velocity with which the ball rebounds after nth impact with the floor. So for motion of the ball, for motion of the ball under influence of gravity after nth impact with the floor, initial velocity in the upward direction is equal to V subscript n, and maximum height is Hn. Using the formula for maximum height equal to U square by 2g. Can I Hn equal to Vn square by 2g? That means, or otherwise, if you use the formula Vf square minus Vi square equal to As for motion of the ball after nth impact with the floor, at the highest position, final velocity is 0. Vn is the magnitude of initial velocity for motion of the ball under influence of gravity after nth impact with the floor. So you can write Hn equal to Vn square by 2g, or Vn square can be written as 2g Hn. So just before this, I have discussed the height to which the ball rises after nth impact to the floor can be written h into e power 2n, or you can write 2g h into e power n whole square. So magnitude of the velocity with which the ball rebounds after nth impact to the floor, you can write, if you take root both sides, e power n into root of 2gh. Root 2gh you can write v. So magnitude of the velocity or speed with which the ball rises after nth impact with the floor, you can write v into e power n, where v the magnitude of velocity just before the very first collision with the floor. If p the magnitude of momentum of the ball just before the first impact with the floor, you can write p equal to mv. So magnitude of the linear momentum with which the ball rebounds after nth impact with the floor, you can write mvn, or mv e power n, or you can write p to e power n. So magnitude of the linear momentum of the ball after nth impact or nth collision with the floor will denoted by p subscript small n, that you can write p into e power n, where p the magnitude of the moment of the ball just before the very first collision with the floor. So next here, like to calculate the total distance which the ball travels before it stops rebounding in between all the collisions with the floor. This result was asked in one of the old IIT papers, and same result was also in 87 IIT JEE paper. You are given a question based on this, and same problem based on same calculation is also given in MSET engineering paper in later years. So the ball first, let D denote the total distance covered with the ball before, in between all collisions with the floor before it stops rebounding. So originally the ball was dropped from height h above the floor. That means h is the original height from which the ball falls freely under gravity before the first impact with the floor. So after first impact with the floor, it rises to the height h1. Remember that to whatever height the ball rises after a particular impact with the floor, next it will fall freely under gravity from same height before the next collision with the floor. So after first impact with the floor, it rises to the height h1. So next it falls freely under gravity from same height h1 before second collision with the floor. That means that this height h1 is covered twice. The distance h1 is covered twice. Then after second collision with the floor, it rises to the height h2. Next it falls freely under gravity from same height h2 before third collision with the floor. Then it rises to the height h3 after third impact with the floor. Next it falls freely under gravity from the same height h3 before fourth collision with the floor. So except the original height h, all the remaining distance h1, h2, h3 are covered twice. So after third impact with the floor, it rises to the height h3. Then it falls freely under gravity from same height h3 before fourth impact with the floor. h4 is the height to which it rises after fourth impact with the floor. Then it falls freely under gravity from same height h4. Like that, you get infinite number of terms here. You can write h plus d equal h plus 2h1 plus 2h2 plus 2h3. You need not copy running notes now, just concentrate only to listen. I will show you the notes separately. Plus 2h4, etc. This h1 you can write h into e square. h2 you can write h into e power 4. Height to which the ball is after nth impact with the floor, as I discussed, given by h into e power 2n. So to find h2, put n equal to 2. To find h3, you put n equal to 3. h3 means height with the ball right after third impact with the floor. That h equal to h into e power 2 into n. That is e power 2 into 3, that is 6. h4 can be found by putting n equal to 4 here. 2n becomes 2 into 4 or 8. Or h4 equal to h into e power 8. And so on. So h plus you can take 2h e square common here. 1 plus e square plus e power 4 plus power 6. You get large number of terms. Very large number of terms. So you have infinite number of terms here. That means you have infinite geometry progression with common ratio equal to e square, which is less than 1. Sum of the infinite number of terms of a geometry progression is given by s equal to a by 1 minus r. This formula holds good when the common ratio is, numerical less than 1. If r is the common ratio and a is the first term, sum of the infinite number of terms of a geometry progression, you can write a by 1 minus r. Where r is the common ratio or magnitude of the, ratio of the second term by first term. A is the first term. Or common ratio you can write third term by second term, or any term divided by previous term. So in this series of terms you have within brackets, the first term a equal to 1. The common ratio is second term by first term, that is e square by 1 or e square. So using that formula you get h plus 2h into e square a by 1 minus or a 1 by 1 minus e square. This you can simplify to find the total distance covered by the ball before it stops rebounding completely. So total distance covered with the ball before it stops rebounding completely, you get d equal to h into 1 plus e square by 1 minus e square. Next, I would like to discuss the calculation for the total time after which the ball stops rebounding. As I have discussed earlier in kinematics, that if a body falls freely under gravity from height h, and the time taken by it to reach the ground is given by root of 2h by g. As I discussed in the case of vertical projection in kinematics, that if a body is given some initial velocity u vertically upwards, such that it moves only under influence of gravity after projection, and time of ascent is same as time of descent. That is equal to half of the time of flight. So in the total time after which the ball stops rebounding, suppose denoted by capital T. First, the ball falls freely under gravity from height h before making the first impact with the floor. So time taken by the ball to reach the ground before the first collision with the floor is root of 2h by g. So after first collision with the floor, it rises to the height h1, and then it falls freely under gravity from same height h1 before second collision with the floor. That means after the first collision and before second collision with the floor, the ball covers the distance h1 twice, that is 2h1. The time taken to fall freely under gravity from the height h1 will be root of 2h1 by g. If you consider the motion of the ball between any two successive collisions, if you consider the motion of the ball under influence of gravity between any two successive collisions, time of ascent is same as time of descent. So if you consider the motion of the ball between the first impact and second impact with the floor, time of descent is root of 2h1 by g. So time of ascent is also root of 2h1 by g. That means the total time for which the ball moves under influence of gravity between the very first impact with the floor and after second impact with the floor will be 2 times the time taken to cover the distance h1 under influence of gravity. That is 2 into root of 2 h1 by g. Similarly, after second impact with the floor, it rises to the height h2, then falls freely under gravity from same height h2 before third collision with the floor. So time taken to fall freely under gravity from height h2 is root of 2 h2 by g. So after second impact with the floor, it rises to the height h2. Then it falls freely under gravity from this height h2 before third impact with the floor. So time of ascent for the height h2 same as time of descent for the same height h2. Therefore, total time of motion of the ball between second and third collisions will be 2 times the time taken to fall freely under gravity from height h2. The same way, you can write the next term as 2 into root of 2h3 by g. This is the total time of motion for which the ball is moves under influence of gravity after third impact with the floor and before fourth impact with the floor. Next, you get 2 into root of 2h4 by g, and so on. The height to which the ball rises after nth impact with the floor is given by hn equal to h into e power 2n. So you can substitute to find in h1, you can take n equal to 1. To find h2, you can put n equal to 2. That is h2 can be h into e power 2 into 2 or h into e power 4. To find h3, you have to put n equal to 3 here. H into e power 2 into 3 or h into e power 6. To find h4, you have to put n equal to 4. N equal to 4. 2 in n becomes 2 into 4, 8. So on. So you can write this as root of 2h by g. The next two term onwards, you can take 2 into root of 2h by g. Root of e square is e. Common outside. In the second term onwards. So 1 plus you get e plus 100 of e power 6 will be e cube, for which you have taken e common outside. So it will be e square, e power 4, etc. Again, you have infinite geometry progression here within brackets, where first term a equal to 1, common ratio is e. So you can use the formula for sum of infinite number of terms of a geometric progression. It is possible to calculate the sum of the infinite number of terms of a geometric progression if the common ratio is numerical less than 1. E is less than 1. So you can write root of 2h by g. Here a by 1 minus 1 by 1 minus e. So you can take next root of 2h by g common there. This can be simplified further to find the total time for which the ball moves before it stops rebounding. So the total time for which the ball moves before it stops rebounding will be root of 2h by g into 1 plus e by 1 minus e. Need not copy the notes now. I will show you the notes systematically later. First, you concentrate only to listen. Next, in the same special case, I would like to calculate the total momentum imparted to the floor by the ball during all the collisions before it stops rebounding. The magnitude of the initial momentum just before the ball strikes the floor for the first time I have denoted by small p. which is equal to m into v, where v is the magnitude of the velocity just before the ball strikes the floor for the first time. The magnitude of the linear momentum with which the ball rebounds after nth impact to the floor is denoted by p subscript n, as I told you. You can write it as p into e power n. So after first impact with the floor, the ball rebounds with a momentum of magnitude p1, which you can write p into e power 1. Let p2 denote the magnitude of the moment of the ball with which it rebounds after second impact with the floor. That can be found by putting n equal to 2 here, and so on. So change in the linear momentum of ball during first impact with floor. So I give the upward direction positive sign here, the downward direction negative sign. Or you can take upward direction as positive axis, the downward direction as negative axis. So final moment of the ball after first impact with the floor is directed upwards, the positive direction. So we write in general way, first Pf bar minus Pi bar. Pf bar is final momentum after first impact the floor, which is directed upwards, so with magnitude P1. P1 into J cap. J cap is the unit vector in the upward direction of positive axis. Initial momentum before impact is directed downwards, negative axis. And magnitude of initial momentum before impact in the downward direction, before first collision with the floor or before first impact with the floor is P. So Pi bar you can write P into minus J cap because it is directed downward. This is Pf bar and this is Pi bar. So you can write it as, so P1 plus P into J cap. So P1 you can write P or you can write 1 plus E into P times J cap. So change in the linear moment of the ball during the first impact with the floor, 1 plus E into P J cap. So if you consider the magnitude is P times magnitude of change in linear moment of the ball during the first impact with the floor will be P times 1 plus E. Same momentum is imparted to the floor by the ball during first impact. So momentum or impulse given to floor by the ball during first impact to the floor is negative of impulse given to the ball by floor during first impact. This is based on Newton's third law. Impulse given to M2 by M1, negative of impulse given to M1 by M2. And the time of collision is small. So this will be in minus of 1 plus E into Pj cap. The negative sign indicates that the momentum given to the floor by the ball is directed downwards. Similarly, change in moment of the ball during the second collision with the floor will be 1 plus E times P1. So P1 is the magnitude of the momentum after first impact with the floor. When the ball after first impact with the floor, it rebounds with momentum of magnitude P1 because the ball moves under influence of gravity between two successive collisions. So magnitude of the moment of the ball just before the second collision with the floor will be again P1. That means after first impact with the floor, rebounds with the momentum of magnitude P1 and moves upwards under influence of gravity until velocity becomes 0, then moves under influence of gravity, returns to the floor with same magnitude momentum P1, but strike the floor downwards. So P1 can be taken as a magnitude of the initial momentum of the ball before second collision with the floor. So magnitude of change in momentum during first collision with the floor is P times 1 plus E. And P is the magnitude of initial momentum before first collision with the floor. In the same way, magnitude of change in momentum of the ball during second collision with the floor, you can write P1 times 1 plus E. Where P1 is the magnitude of momentum just before the second collision with the floor. Similarly, magnitude of change in momentum of the ball during the third collision with the floor, you can write P2 times 1 plus E. Where P2 is the magnitude of momentum after second impact with the floor, like that. So I am going to summarize the whole discussion now, and I am going to show you the notes for what I have so far discussed in the special case. So those who are writing the notes, come on, get ready with your notebook and pen. So next I am going to summarize the discussion I have done so far about the special case in this class. So those who are writing the notes, come on, get ready with your notebook and pen. You can start writing the notes. I am going to first show you the summary of all the conclusions first. Later I will show you the working part also, because sometimes you may not be able to remember some of the conclusions, but you should know how to arrive at the conclusion by calculation. So come on, look at the screen. I am going to read out the notes. So let a ball be dropped from a vertical height h above a horizontal floor and allowed to make repeated collisions with the floor, so that the ball moves only under the influence of gravity between two successive collisions with the floor. Then first conclusion. The vertical height through which the ball rebounds after nth impact with the floor is given by h subscript small n equal to h into e power 2 into small n, where e is the coefficient of restitution between the ball and the floor. Come on, all of you first finish writing the notes up to this. So you can take a pause now and complete writing the notes up to this step. Next, I am going to show you the notes for the continuation of this special case. That means I am going to show you the other conclusions for the same special case. You may need more time to copy the notes. You can take a pause and take your time to finish writing the notes up to this step, up to here. Next, I am going to show you the second conclusion in this special case. The linear speed with which the ball rebounds after nth impact with the floor is given by v subscript small n equal to v into e power small n, where v equal to root 2 h is the linear speed of the ball just before the first impact with the floor. And third collision, the total distance covered by the ball before it stops rebounding from the floor is given by d equal to small h into 1 plus e square by 1 minus e square. Come on, all of you first finish copying the notes up to this conclusion. You can take a pause and take your time to copy the notes, because all the students do not require same time to copy the notes. Therefore, you take a pause and take your time to copy the notes. I am going to show the continuation for this. First conclusion, the total time after which the ball stops rebounding is given by capital T equal to 1 plus e by 1 minus e whole multiplied by root of 2h by g. The magnitude of total momentum imparted to the floor during all the collisions before the ball stops rebounding is given by p subscript t, means total momentum, 1 plus e by 1 minus e into p. That p is the magnitude of momentum of the ball just before the impact, just before the first impact with the floor. Here p is the magnitude of the momentum of the ball just before the first impact. You must write first. P is the magnitude of the momentum of the ball just before the first impact with the floor. You should write first. So you can take a pause and finish writing the notes up to here. I am going to show the notes continuation for this. That means I am going to show the working for all these conclusions. The ball dropped from height h above the floor, and u1 is the velocity of the ball before the collision, very first collision with the floor. u2 is 0, that is velocity of the floor before collision is 0. v2 is 0, so velocity of floor after collision also 0. v1 is the velocity of the ball after first impact with the floor. h1 is the maximum height to which the ball rises after first impact with the floor. So if you consider the motion of the ball after first collision with the floor under influence of gravity, maximum height h1 you can write v1 square by 2g as I explained before. So for motion of the ball before first collision with the floor, use the equation in kinematics. For motion under gravity, v square 1 square equal to s, you can write v square 1 0 square equal to gh, or mod of v bar is root 2gh. E equal to v2 minus v1 by u1 minus u2. I am going to use this equation for first collision with the floor. v2 is 0, u2 is 0. So you get E equal to minus v1 by u1. Come on, all of you first finish copying up to here. Can take a pause and take your time to copy up to here. Next I am going to show the notes continuation to this. So v1 equal to minus EU1. So v1 square you get E square into u1 square. That means I am showing the calculation for first part of the conclusion. So v1 square you can write 2gh1 and u1 square equal to 2gh. So h1 equal to h into e square, or h1 equal to h into e power 2 into 1. So the final height to which the ball is after an impact with the floor is equal to e square times the initial height. So using the same conclusion, for second collision with the floor, initial height is h1, final height is h2. So h2 is square times h1. You can write h1 equal to h into e square. So you get h2 equal to e power 4 into h, or e power 2 into 2 into h. So for third collision with the floor, h2 is the initial height and h3 is the final height. So again using the same equation, h3 can be e square times h2. h2 is the initial height from which the ball falls freely under gravity before third impact with the floor. h3 is the final height to which the ball rises after third impact with the floor. Then you can write h2 equal to h into e power 4. So you get h3 equal to e power 6 into h, or e power 2 into 3 into h. Similarly, h4 equal to 2 power 4 into h. Height to which the ball rises after nth impact with the floor, you can write h e power 2n times h. You can take a pause and finish writing the notes up to here. I am going to show the notes continuation to this. hn equal to v1 square by 2g. So that means if you have used the formula for maximum height after nth impact with the floor, can add hn equal to v1 square by 2g. Vn is the maximum velocity with which the ball rebounds after nth impact with the floor. So v1 square equal to 2g hn, or 2g hn you can write h into e power 2n. So vn equal to root of 2g h into e power n, or vn you can write v into e power n. Come on, finish copying up to this step. In case you need more time, you can take a pause. I'm going to show the notes continuation to this. Total distance covered as explained. Before you can write these steps yourself. Already I given the explanation. I'm just showing the notes for that. You finish writing the notes up to this step. You can take a pause and take your own time to copy the notes. I'm going to show the continuation to this. So you get d equal to h into 1 plus 2 e square 1 minus e square. After simplification, you get this conclusion. D equal to h into 1 plus e square by 1 minus e square. Come on, take a pause and complete writing the notes. Next, I am showing the calculation for fourth conclusion, which I already explained you. Need not explain the same thing again. You can just copy the notes now. But you should get convinced of each step here. In case you are not convinced of any particular step, again go back to the previous discussion and go through the explanation again. You can take a pause and take your own time to copy the notes. I am going to show the continuation to this. You get total time after which the ball stops rebounding 1 plus E over 1 minus into root of 2 H by G. You can take your time, take a pause and take your time to copy the notes. I'm going to show the continuation. So magnetic velocity of the ball after nth impact V in T power n. Where V is the magnetic velocity of the ball just before the first impact with the floor. So magnetic moment of the ball after nth impact floor, you can have MVN or MV in T power n or P in T power n. So change in denote of the ball during first impact with the floor. You are given positive sign for final momentum in the upward direction, negative sign for initial momentum before collision in the downward direction. Come on, finish writing. Already explained this calculation up to this step. You can take a pause and take your own time to complete the calculation. I am going to show the continuation to this. So linear momentum or impulse imparted flow during first impact of negative of this minus P into 1 plus E. You can take a pause and complete writing the notes up to here. I am going to show the continuation to this. Come on, take a pause and finish writing the notes up to here. So in my next class, I will discuss the case of ballistic pendulum, etc. Can take a pause and finish writing the notes up to here.